Okay, so here's the third proof, and this comes from geometry. And this is proof number 7 in the Cut the Knot list, and this is actually the proof that Evelyn Lamb thought was really interesting, and she posted about it. And it is attributed to a guy named Tom Apostle, who wrote a really awesome calculus textbook, among other neat things that he did. Okay?
Yeah.
And the only geometric fact that we need that you probably haven't seen before is that if I have a circle and a point outside of the circle,
Yep.
and I draw tangent lines. Now, what are tangent lines?
They're lines that just touch the circle in one point.
They're lines that just touch the circle in one point. If I draw tangent lines to the top and to the bottom of the circle, from a point outside the circle, these two lines have an equal length.
Yep.
Okay, and the reason is actually pretty simple. You can imagine drawing a line from this point to the center of the circle, and the tangent lines are perpendicular, it turns out. That's probably another fact you didn't know. But you can see that if I draw a line to the center of the circle, or you can imagine those angles are going to be equal, and I got a right triangle, so I've got two triangles that are the same.
Yeah.
And so those lengths have to be the same. Don't worry about that. We're going to use this fact, and I just wanted to show you quickly why that fact is true. Okay? So, we have a right triangle, 1, 1, square root of 2. How do I know that if I have a right triangle with side length 1, side length 1, that the hypotenuse is the square root of 2?
The Pythagorean theorem.
Yeah. Pythagorean theorem.
Pythagorean theorem.
A squared plus b squared is c squared.
Okay, now if the square root of 2 equals a over b, where a and b are integers,
Yeah.
I can just multiply everything by b,
And
and I can get a side length b, a side length b, and a side length a there.
so that
And the
means
Pythagorean theorem in this case would say what?
a squared plus b squared is b squared plus b squared is a squared.
B squared plus b squared is a squared, which
True.
simplifies to be
2b squared is a squared.
just like we've run across in the two prior proofs, right?
Yeah.
And the fact that these are in lowest terms as the ratio means this is the smallest triangle for which this is true, that I have integer sides
Yeah.
that have this relationship. Okay? Now, Tom Apostle does something really cool here. Remember, this is the smallest triangle.
Yeah.
He draws a little circle here. So that this is b, and this is a minus b on the hypotenuse.
Yeah.
Okay. So here's my radius of the circle up here, and he just swings it up, so I have a piece of a circle here. Then he draws the tangent line down to here. Alright?
That's not a right oh, wait. Oh.
It is a right triangle because that's the tangent line.
Oh, yeah, it's just upside down.
Okay? Now this was a 45-degree angle before, right? But it's the same angle that's in our smaller triangle and big triangle. And this is a 90-degree angle. So what does that mean this angle must be?
45.
45, which is the same as this angle. In other words, this triangle here, this little one and the big one, are the same kind of triangle. They're similar to each other.
So it wasn't the smallest.
Well, hold on. Maybe this one doesn't have integer sides. Okay, we don't know that it does. But because this is 45, 45, it's similar to this one. That means this side here,
Is
B, also must be A minus B.
Yeah.
Okay? What can you tell me about A minus B?
Well,
well
What's the only thing we know about A and B?
A and B are in lowest terms.
They were in
Yeah.
lowest terms.
so
There's something else that's
And-
important about them.
A has to be bigger than B.
A was bigger than B, yeah.
So it means it's positive.
It means this is positive, but even more important than it being positive, what are A and B? What's special about A and B?
They're in lowest terms.
They are in lowest terms.
And
Something else is special about A and B.
these, well, this A and B are the smallest integers.
Wait, A and B are what?
A and B are the smallest integers.
What's that word you just said?
Smallest
The next one?
integers.
Integers.
They're
A and B are integers. That means A minus B is what?
A minus b is an integer.
A minus b is an integer. So this side has integer length, this side has integer length, right?
Yep. So that means this side's gonna have integer length.
Not necessarily, because remember 1, 1
Yeah.
square root of 2. But here's the fascinating thing. Because I have tangents going from this point here and this point here, that means they have to be the same. So this side is a minus b, which makes this side a minus b plus whatever this is, x, has to add up to b. Right, because this side's b?
Yeah.
So what is, can you solve for what x is?
Well,
A minus b plus x is b.
Yeah.
Well, you can add b to both
You
sides.
can add b to both sides. A plus x equals
2b.
2b.
So x is 2b minus a.
X is 2b minus a. So this side is 2b minus a, which is what?
Which is an integer.
Which is an integer. So wait a minute, I said this big triangle was the smallest triangle that gave me BBA,
Yeah.
but I just found a smaller one.
What?
What does that mean?
It means it's not the smallest.
It means it wasn't the smallest. But if the square root of 2 was a over b,
That means the
I could find the smallest triangle. So what does that mean?
square root of 2
Is irrational.
The square root of 2 is irrational. Just from some really clever geometry.
Yeah.
And the fact that integers minus integers are what? Cool, right?
Yeah.
Alright. So now we've seen the standard proof, a number theory proof, and a geometry proof, and now we're going to go to continued fractions.
Hmm.
Whoa.